other type of measurements of flow, either volumetric or mass flow. We have the thermal, we have Coriolis effect, we have paddle wheel, which this makes a lot of sense. We have magnetic one, we have positive displacement flow meters, and propellers are the most common ones and cheap ones. So first things first, the thermal one is relatively, let's say, complex, and at the same time it's easy. They have this, so you got temperature sensors right here. You heat something, and then they will make the difference, and will make a formula or analysis on the difference on temperatures. And depending on the fluid, they will calculate the difference of gradient, and they will tell you the velocity. I know it's kind of strange, tricky, but it actually works. The Coriolis, it's a little bit, let's say, not that common sense, but it's easy. You have these flow mirrors, coils, and here. So you got sensors right here, and they detect the force and the velocity right here. So with calculating the differences, or the force, if they calculate the pressure and the force, you will be able to make the difference. Of course, it's always about making the delta, the change, the difference, and then they will tell you the velocity or flow rate or mass flow. Okay. The paddle wheel, well, is one of the most obvious ones. You have this right here, you install it in your pipe, and flow will flow and move this paddle wheel, and as it moves, you know that for every revolution there's certain distance, and you can relate distance to volume, and yeah, with volume and time you have your volumetric flow rate. This one is kind of crazy, even though it's actually pretty extensively used in the industry. It's the magnetic flow meter. So you have this magnet right here, or not magnet, but this equipment right here, and they will generate a magnetic field, and they will calculate the difference on that magnetic field, and then calculate the velocity. This is way more out of the scope of our course, so I'm not going to explain it truly. This one is pretty similar to the paddle wheel. They will start moving. For example, they go here and they start moving, and when they move you can count them, count the number of wheel or revolution they have, and relate it to the volume or the flow rate. Propeller, yes, pretty similar to that one of the wheel, but instead of having, let's say, axial right here, we will have it with respect to the transversal flow. So the faster it flows, the faster it will spin. The more it spins, the more it registers revolution per minute, and you will have a revolution per minute table versus volumetric flow rate. And yeah, I think it's everything, guys. This was a free preview. You want to get full access, go to my incompressible flow course. The link is in the description of the video. You will get all access. Not only that, you get a very straightforward, user-friendly interface. So for instance, if you were analyzing or studying pumps, you have it here, the pump block, and then you have the sections. If you were, for example, studying the types of pumps, you can go here, and you have all the classes right here. Not to mention that you also have introduction and conclusion of every one of these. So for instance, if you were studying positive displacement pumps, the video is right here. If you were studying positive displacement pumps in rotatory and reciprocal, are also included here. Centrifugal pumps, which is a very important topic in this course, you have it right here.